So here is the list that I came up with it. Step number 1. Anyone want to take a guess at what step number 1 is? What did you say? Examine the equation. Good. We're going to examine it and then do what with it? It's a very, very simple thing to do. It's not math at all.
Write it out.
It's already written out. What do you guys always do first? After you read it. There we go. Fence. What do I normally say? Cross down your equal sign? Cross out your equal sign? Draw a line? Whatever. Draw a line through the equal sign. It's such an innate part of what we do now that we don't even register it as a step, I think, is why we couldn't come up with that. Draw a line through our equal sign. Okay. Yes, we are looking, we are reading, we are assessing our situation. The first thing that we're going to look for to assess is parentheses. When I see parentheses in my equation, what does that tell me I need to do? Multiply. More specifically, a word that starts with D. Distribute. Outside number to each term inside the parentheses. I'll give you guys time because I know some of us write a little bit slower, but that's okay. That's going to be the first thing. We're taking notes. Jeremiah, you got your notebook? You want a piece of paper? Just do it on the back of this. Just glue it in there. So we got to clear out those parentheses. We got to distribute, get everything on the same plane. All right? After distributing, I'm going to have kind of a lot going on. In some equations, I might have like 6 to 8 terms, okay, going on. So I got to clean those up. That's what I always say. We got to clean this up, right? What's the technical term for cleaning up? Combine like terms. That's right. Combine like terms. Okay? More specifically, we got to combine like terms that are on the same side. Another reason why step 1 is drawing our little fence down the equal sign. So I know what's my left side, what's my right side. I can only combine like terms that are both on the left, or only combine like terms that are both on the right, right? Right. Okay, after we do that, we should have a variable term and a constant term on the left side with a variable term and a constant term on the right side, okay? That tells me now it's time to do inverse operations. Now we're going to break these inverse operations into 3 steps. Step 4 is to bring your variable term to the left by doing inverse operations. We're not going to write that part because we set it up with our little inverse operations zone. But I will say, by either adding or subtracting. How do I know whether I'm adding or subtracting my variable term on both sides?
Because if it's a positive, then you have to subtract it. And if it's a subtraction sign, then you have to add it.
That's right. Thank you, Lola. We just do the opposite of what we see. If I see a positive x term, I've got to subtract it. If I see a negative 3x, I got to add it to both sides. Okay? Obviously, once I bring my variable term to the left, I got to bring my, what's the opposite of a variable term? Constant term. Good. To the right. Now again, technically it does not matter which side your variable term is on and which side your constant term is on. But I like teaching it this very specific way because I like steps that are very easy to follow and understandable and repeatable every single time. Once again, by doing the opposite, either adding or subtracting. There should be no multiplying and no dividing anywhere yet until the very, very end. Step 6, we're going to get the variable by itself by dividing. Right? We're going to get the variable by itself by dividing. After I finish step 6, I should have something like x equals 2 or b equals 4. What's the only thing left to do once I have my answer? We already divided. That was step 6. What comes after that? Yep, that's step 6. What did we learn on, was it this week? No, at the end of last week that we had to identify? How many solutions we have? Identify how many solutions. That wasn't just one standalone lesson. That's now part of our toolkit that we're going to use every time. Identify how many solutions we have. Either one, none, or many. Every single equation that you are going to solve will follow this checklist in this order. Now, not every equation is going to require that you do all these steps. But being able to recognize when I can do one of these steps and when I do not need to do one of these steps is extremely important in you being able to do this work. Right? If I go through, like I have an equation in front of me, and I don't see any parentheses, do I need to distribute anything? If there's no parentheses in the equation, then there's nothing to distribute. I'll just skip that step and look to combine like terms. Maybe there's no like terms to combine. That's fine. I'll skip it and bring my variable term to the left, my constant term to the right, and then divide. Okay? So step 4, 5, and 6, those are my little inverse operations. That's most of the work. Right? Once we get it all cleaned up with distributing and combining like terms, a majority of our work is just doing the opposite thing of what we see, the opposite operation. And then just identifying how many solutions we have. Right? Now, let's say, if I have something like 2x plus 3 equals 2x plus 6, right? That puts me now in my inverse operation zone. I'm going to bring my variable term to the left, step 4. So this 2x is going to get brought to the left. What happens to my 2x's here?
They cross out.
They all go away, leaving me with 3 equals 6. Do I need to do step 5 of bringing my constant term 3 over to the right? No. I skip step 5. There's nothing to divide because there's no variable. I skip step 6. I go right to step 7. What could I do with this with step 7? Identify how many solutions. Well, how many solutions would this give me? None. No solution. So even in our special cases, we can still follow this checklist and just skip what we don't need to do and move on to the next thing. Okay? The only step that you will do every single time is step 1 and step 7. Okay? Every equation will be a combination of all the steps in between, but you will always strike through your equal sign to separate your equation into 2 parts, and you will always identify how many solutions you have. Okay?